London Chess Centre, Europe's oldest chess shop. Chess is one of the oldest games, dating back from about the 15th or 16th century. It's pretty complex, and that's one of the reasons it's so appealing. So, there are 6 different pieces: the rook, the knight, the bishop, queen, king, and pawn, and each moves a different way. And so that's one of the reasons it's so complex. So, take a look at the opening position on this board. There are 20 different moves that white can make. White always goes first. White can move one pawn either forward 1 square or 2 squares, and it has 8 pawns, making 16 possible moves that pawns can make, or the knight can move either here or here, and this knight can move either here or here. So there are 20 possible moves that white can make, and likewise there are 20 possible moves that black can make. So here's a question. If this is one position that is possible on the chessboard after white moves and black moves, how many different possible positions are there? Here's another possible position. So again, there are 20 different moves that white can make, and there are 20 different moves that black can make after the first move. How many possible positions are there on the chessboard? So to help you as you think about this problem, here's a possible position. Or maybe white will choose to go here. Here's another possible position. Or maybe white will choose to go here and black there. There's another possible position. Or maybe this pawn. There's another possible position. If you said 400, you're correct. There are 20 moves that white can make and 20 moves that black can make. 20 times 20 is 400. So now here's a question. How many possible positions do you think can happen in total? Any chess game, any number of moves, how many different positions are possible for any chess game? The answer is 2 to the 155 power. That's 2 times 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 2. You get the point. To the 155 power. It's a lot. Cut. If you still don't understand that there are 400 different positions possible after white moves and then black moves, don't worry. Maybe you will after this lesson. Welcome to Intro to Counting. The goal of this lesson is to introduce you to basic principles of counting. So this includes combinations, how many ways can we combine different objects, and ordering, in how many ways can we order a select group of objects. Hi, I'm here at the Giraffe restaurant. For dinner, I want to order 1 appetizer and 1 entree. There's so many good options, but I've narrowed the number of appetizers I want down to 2, and the number of entrees down to 3. So how many different combinations of appetizers and entrees can I make? So you have 2 appetizers. Let's call them A and B, and 3 entrees. Let's call them 1, 2, and 3. So you could have appetizer A with 1, or A with 2, or A with 3, or you could have appetizer B with entree 1, or with 2, or with 3. So there are 6 total combinations of appetizers and entrees. Or we could write it like this: A with 1, A with 2, A with 3, B with 1, B with 2, and B with 3. And we could also think of it like this: 2 appetizers times 3 entrees, which equals 6. I'll have the edamame and the super healthy veggie salad.
No problem.
Okay, Now let's test how well you understand this concept. Let's say you're trying to decide what to wear tomorrow. You have 5 shirts you're going to pick from. 1, 2, 3, 4, and 5. 2 pairs of pants. 1, 2. And 3 pairs of shoes. 1, 2, 3. Now let's add in another clothing item. Let's say you can either wear a hat or not. Now how many outfits do you have? How many combinations of shirts, pants, shoes, and hat or no hat? So you have 5 shirts, 2 pairs of pants, and 3 pairs of shoes. So you could have this shirt with this pair of pants and those shoes, or this shirt with this pair of pants and those shoes, or with this pair of pants and those shoes, etc. You get the point. So, how many different options are there for outfit combinations? 5 times 2 times 3, which is 30. So now pair in the hat or no hat. Even though there's only one hat, there are 2 options. So multiply it by another 2 for the hat, and then there are 60 possible outfits. Okay, let's say that of those 5 shirts, you want to wear a different one every day, Monday through Friday. How many different orders can you do this? Well, let's think about it. How many options do you have on Monday? 5, because you haven't worn any of the shirts yet. But on Tuesday, you only have 4 options because you've worn one of the shirts. On Wednesday, you have 3 options, Thursday 2, and Friday 1. So let's just focus on Monday and Tuesday for a sec. You have 5 options on Monday and then 4 options on Tuesday. In how many ways can you wear these 2 shirts? So let's say we have shirts A, B, C, D, and E. You could wear first shirt A, then shirt B, or you could wear shirt A and then C, or you could wear shirt A and then D, or shirt A and then E. Or you could wear shirt B and then A, or B and then C, or B and then D, or B and then E. And there are a bunch more options for the orders in which you could wear shirts on Monday and then Tuesday. So try and finish the rest. So after the first 2 days, how many ways could you have worn your shirts? 20. Let's keep going. On Wednesday, you have 3 options, and then on Thursday 2 and Friday 1. So how many ways could you have worn your shirts total over those 5 days? What do you think? If you got 120, you're correct. And you may have noticed that we do this by doing 5 times 4 times 3 times 2 times 1. And after the first 2 days, we just have 5 times 4, which is 20. One goal, as I mentioned previously, is to be able to write these ideas in symbolic form. So that's what we're going to do now. So we have 5 days, or alternatively, we could have n days, any number of days. What we just did when we found the total number of orderings that we could wear those shirts over 5 days is n factorial, which basically means n times n minus 1 times n minus 2 all the way to 1. So 5 factorial is 5 times 5 minus 1, which is 4, times 5 minus 2, which is 3, times 2 times 1. So that's relatively simple, but what about after 3 days? So you found that after 2 days, there are 20 different orderings that you could wear shirts. Let's try and put that concept for some number of days less than n into symbolic terms. Let's look at after 3 days since we already looked at after 2 days. How many different shirt options did you have for the order? 5 times 4 times 3, which is 60. This is like saying 5 times 4 times 3 times 2 times 1 divided by 2 times 1. Do you see why that's the same as this? Because the 2 times 1 cancels with the 2 times 1. And another way of writing that is 5 factorial divided by 5 minus 3 factorial. So if we're going to write this in general terms, this is n factorial divided by n minus r factorial, where r is the number of events that we're looking at. So in the case of shirts, it was 3 days or 2 days. This is called a permutation. Now that you figured that out, here's one last question before we move on to the next lesson. Let's say that you've narrowed the number of countries you want to visit down to 10. So you're trying to decide where to go next year and the year after and the year after. So you could go to Brazil first, then the Philippines, then Thailand, etc. Or maybe you would go to the Philippines first and then Brazil. So how many different ways can you travel over the next 10 years? Okay, and now one more question, part B. How many ways can you travel over the next 5 years out of those 10 countries that you want to visit? Here's a puzzle to ponder before the next lesson. Let's say you're at an amusement park. There are 15 rides, but you only have time for 3 rides. How many groups of 3 rides could you choose? So this isn't about ordering anymore. This is about how many groups of 3 rides can you choose to do in the time you have left at the amusement park. And there are 15 rides total. You can think about that, and in the next lesson, we'll explore how to derive the number of groups you can create out of a certain number of objects.